Hello, welcome back to making a mini Rust in Rust. This is video 12. And if you're watching this video, you have the privilege of, hopefully, watching our parser go from a kind of a toy that's like a bit of a fake parser that can only parse like really specific silly cases into something that looks something like a real parser, which can backtrack, and it kind of knows when to stop because it's reached the end of an expression. So that's what I'm hoping we're going to end up with out of this. So if you're watching the last video, what we concluded with was we can parse expressions, but our parser doesn't yet know how to, when it hits a semicolon at the end of an expression, how to say, okay, take the expression that you were just working on and now treat that as a statement. So basically, a statement is a thing that ends in Rust. A statement is a thing that ends with a semicolon, which means that we're kind of done with the value that it produced, and we just want the side effects that it had. For example, like creating a variable, or even returning or something like that. So generally, a statement is an expression followed by a semicolon, which means stop parsing the expression and just ignore the value that comes out of that expression. So what we have been writing so far is really an expression parser, and an expression parser that doesn't know when to stop, I think is a fair way of putting it. So we're going to need to get a bit cleverer. And what we talked about at the end of the last video, which I think is still right, is we're going to need the code we've written so far to be something like expression. And parseNext is going to call expression, like self.expression. And when we call expression, we're going to need to pass in a list of things that mean that you've reached the end of an expression. So we did, hang on, we named this somewhere else. Where did we name it? In leaf or operation, we named it end markers. So end markers is a list of stuff that means stop parsing this expression because we're done. So we're going to call it end markers as well. We'll go back to where we were. An expression is going to take in a list of things that mean you've finished this expression. And that is going to be, I mean, it doesn't need to be a vec, does it? It should be some kind of reference to, like a slice of some kind. And then maybe we make a vec, or maybe here, this will just be a slice of, and it's going to be token kinds. And in this case, when we are that's interesting, isn't it? Like in this case, semicolon, it has stuff in it, but we don't care. Oh, this is a bit annoying. Are all of the things that end an expression always going to be things that don't have anything interesting inside them? But they do have something inside them, because so far all my token kinds have something like this inside them. So we could say basically stop if you hit something that equals this. So I guess that's okay. It feels like a bit of a waste. Also, this feels like why am I repeating myself saying semicolon and putting a semicolon there, and I have to do this to owned thing? It just feels awkward. But let's leave it for now. Let's put in a little bit of a to-do here. Constructing this semicolon feels awkward. And maybe we'll come back to that. Anyway, what we're saying is parse our expression and stop if you hit a semicolon. And later we'll have other things you want to stop. Like if you've just hit an open bracket, you want to parse an expression and stop when you hit a closed bracket. Things like that. So now once we've parsed the expression, like so, it might be none because we might have actually hit the ends of the tokens. If it's none, then we'll just quit, right? So we'll just question mark it. That means if this expression is none, return none. So now expression is a result of syntax tree blah. So I guess if it's an error, we also want to bail out. So we can do something like match expr. And if it's an error, then we just want to return some E, I think. So I guess we could do some kind of let else here. No, because we need the E, that's the point. So it should be return some. Like so. Can we have that? Or does that just be in curly brackets? Like some error E, like this. If it's not, then we're going to carry on. So this is going to be expr. If I could type things. So now the type of semicolon. So the type of expr is a syntax tree. So now we've got a syntax tree because otherwise we've quit out early. And that's fine. But then we need to find the next token. We finished parsing this expression. So either we've hit the end of the file or we've got some other token that was one of these end markers. In our case, we only passed in one end marker, so the only possible end marker it would be the semicolon. So let's get the next token, which is, and we've got this self.tokens.next thing, and it's either going to be none, in which case we quit again because we're done parsing and we're returning an expression, or it's going to be something. So now we've got a token. And we've got an expression. And if it's a semicolon, we're good to go. And if it's not a semicolon, then something funny's happened. So we better check, I guess, just in case. So if let token kind semicolon equals token dot kind. So if it's a semicolon, do something good. Otherwise, do something bad. I guess parse next is going to be, it's parse next statement. So we might want to call it that. We'll see. So if it's not a semicolon, we're really confused. So we're going to return some kind of error, which is saying, it's like an internal error. Like we said, don't stop parsing until you hit a semicolon. And then we hit a semicolon. We stop parsing, but it's not a semicolon. So something funny is going on. So for now, let's experiment with just saying, yep, it is an internal error. Internal parsing error, I guess. Parsing error. So let's define that error type here. Internal error. I guess it's an internal compiler error, right? I mean, it's an interpreter, but these are generally referred to as internal compiler error. internal parsing error. Let's say internal parsing error, right? And where did it happen? Well, around about the current token, I guess. So we'll have something to say about what happened. And we've got some example code of how we make errors. Here's an example. It's going to be similar to this. At some point, we're going to need a file name, aren't we? It's going to make this stuff harder or easier. And then we have to do a dot into like this. And token, I guess it's at the point of, yeah, token. And there's more we can say here. So we should say something like to do. There must be, yeah, we haven't taken up the full flexibility of me yet for what we can put into our error messages. So here it's like we asked to stop parsing when we hit semicolon, but we stopped after hitting something else. So this should be like, say this. So again, we're putting off error handling, but hopefully we won't put it off too long. So that's the error case. And then the OK case is, we did hit a semicolon. We've already parsed an expression. We hit a semicolon. So all we want to do now is just wrap up that expression in a statement. So it really is as simple as that. Oh no, it's not as simple as that, because it should be some. In fact, we can wrap the whole thing in some, can't we? So let's do that. So some. Are we okay with that? It looks a bit messy to me, but and it's an okay thing because we hit the thing we expected to hit, and it should be a box. Like that. Okay, so that is, I think, the full implementation of parse next, which we might want to call parse statement, or parse next statement, something like that. Or we at least add a comment saying parse the next statement from the stream of incoming tokens. Something like that. But we're not actually using, this is like guessing that this semicolon thing is going to be used. It's not being used. So end markers needs to be passed into, I guess it needs to be passed into assignment. And it probably also needs to be passed into leave for operational unrecognized. Let's just guess that it does. And then please just make that, okay, it's not going to do it for me, I have to do it myself. So where does end markers go? Does it go before token or after token? We passed it in before, but I think, after, but I think it goes in before. I think it's the first thing you pass into every, in fact, in a way, you could say that there should be some kind of struct or class that encapsulates the fact that we are currently we're like in a sub-parsing mode where we're parsing, looking for these end markers. So maybe it should be in self somewhere. But for now, we'll just pass it in. That's fine. And these end markers get passed into assignment. And we are going to stop parsing. Well, we stop parsing an assignment just because it only consists of let blah equal blah. So we already know to get to the end. So we're not actually going to use these end markers. But that's a little odd. So I'm still going to allow you to pass them in. And because it feels like everything should know when to stop. And certainly, oh yeah, we are going to use it. We are going to use it because the sub-expression here, when we're parsing the next expression, this shouldn't be parsed next because it's not looking for a statement, it's looking for an expression. So that is going to have end markers passed in. Yeah, that makes sense. So now at the end of our assignment, we're parsing an expression, and we start parsing that expression when we hit one of these end markers. That makes perfect sense. So I think that's good. And then this one is also going to be able to take in end markers. This function's long, isn't it? Assignment is long. Maybe we should think about breaking it up. And by the way, we also are going to think about maybe parser shouldn't all be in one file. Maybe some of these methods belong in their own file, and you can do that in Rust. You can have parts of methods of a struct across multiple files. Whether you think that's good or bad, I don't know, but I think in this case we're going to want to do it. Okay, so I passed in end markers. Oh, but we declared it as a vec here. It shouldn't be a vec. That was just us not thinking clearly about the type of it. So now we've got to leave our operation. We've got end markers here. And we've already we wrote at the end of last video that when we're trying to parse this thing, we have some kind of leaf node, and it might be followed by an operator. So we were saying, like, try and find an operator, and if it's not an operator, then we're fine. But actually, it also might be just one of our end markers, in which case we should stop reading, and actually we should give the token back to the stream, like push it back into the stream, so that next time we call next, it comes back out again, which is why, the reason why we need this is because if we look back at our original thing, when we do tokens.next here, we need the semicolon to come out. We need to have not consumed it already. Yeah, so we know that we need this kind of give back, which allows us to backtrack, if that's the right phrase. We haven't implemented that yet. If we implement that, I now think our guiding test that we're working on will pass. So let's look back at our guiding test. Here, what it says is, when you parse this statement followed by this expression, you should get out a statement and then an operation, which is a type of expression. And I think if we get this stuff right that we have now planned, this test will pass. We can stop ignoring it. But we need this give back thing to work, and we don't know whether naming it give back is right. But it's the best name we could come up with so far. Suggestions and comments welcome. I still haven't renamed symbol to identifier, but we'll do that. All right. So in order for tokens to have a give back method, it's got to be not just an iterator, but something else. So let's have a look at tokens. So a parse, which is what we are, we're an iterator. We implement iterator. We implement iterator. Let me get this right. We implement iterator, and the item that we return when we iterate is a result of syntax tree, right? So when you get given a parse, you can then iterate over it, and each item in that iteration that you do is a result, which because you might or might not have succeeded in parsing the next few tokens. But if you did succeed, you get back a syntax tree, which is like a collection of, like a tree shape that says, these tokens had this meaning. And that's a thing like an assignment or a statement or a operation, like something plus something or something like that. So parse is an iterator, but parse also uses an iterator of tokens. And it's tokens that we're talking about here. And so far we've just said tokens is some I which implements iterator where the item is a token. But we now need some special trait which is cleverer than that. Do we need a trait or an actual struct? Maybe just a concrete struct is the right way to think about this. We'll see how it goes. And this is going to be tokens. No. It's going to be it's going to be like a backtrackable iterator. And I guess it's going to hold on to something which is itself an iterator. So it's going to have this I thing with this where thing. I want to write some tests for this, and I want to write this in a separate file. So let's do that. So we're going to have backtrackable iterator. Well, what did I say? I said give backable. I said give back. So is it a give backable iterator? I don't like that, but I don't like backtrackable because... No, okay, I think backtrackable kind of expresses what it is. We'll start with that and we'll think of a better name if we can. So a backtrackable iterator looks like this. And it's going to have some tests. Not sure how long. I mean, it turns out that the last video was really long and I hadn't even noticed. Hopefully this one it won't be so long, but this could get tricky, so we'll see. So it's going to be like, first of all, you can iterate through it, can't you? So iterating through backtrackable iterator yields all items. So let it equal a backtrackable iterator of something already that is already an iterator, right? So we're going to give it, let's give it like just some things. It doesn't matter what they are, right? We're just going to iter those. So basically you can construct one of these things from an iterator is how I'm thinking about it. This doesn't seem to be compiling, which is slightly worrying. Oh, I guess I didn't save the changes to other files that made it compiled. Yeah, there we go. All right, so this isn't going to be an iterator of item equals token. It's going to be an iterator of some type like value, I guess we call it. Item equals v. Whoops. It's going to be very general, this backtrackable iterator. It's not going to be a thing, and then it's not going to be specific, and then here we're going to do it's going to hold on to item inner, let's call it, which is an I. So now it's not complaining about how I and v are not used, because they are. Now we can generate a new function which takes in a inner and holds on to it. And this should not be, this should be an iterator. This should be an I, right? Like this, same where here. Which means we need I and v here. A lot of typing to do this generic stuff. Okay. So, what's it saying? The trait iterator is not implemented for slice iter. What? How is it not? Slice? Oh, reference. Should I be doing that? Okay, fine. That was confusing. I could have just bracketed that up again, I guess. But anyway, all right. So now it's not a slice, it's an array, but we just iterate through it, so it's fine. All right, so we've got a backtrackable iterator. We need to make an assertion about it. I think what we're going to assert is that when you collect all the items in it into, let's say, into a vec, like so, then the answer is going to be the same as what you put in. A, B, C. Backtrackable iterator is not an iterator, but it is, because we're going to make it one. So impl iterator for backtrackable iterator, we're going to need some i's and v's here. IV, same where clause as before. I guess maybe we don't even need it. Sometimes you don't need that where clause because it's only if the actual code inside makes use of it. And then the item here is going to be v, because we're wrapping an iterator to make it something that's also an iterator. And the first implementation is just going to be like the dumbest possible thing. When you call next, you get back inner.next. So the first thing is just going to make this test pass. We've got some kind of ampersand str versus str problem. So what is? Let's maybe collect them. So call it C. Collect it into here. What's the type of C? It's a vec of ampersand str. So what if we just said we want it to be a vec of ampersand str? Would that work? Oh no, this needs to be into iter. I guess that might fix our problem. Yeah. So let's do it this way anyway. So we got it nice and straightforward. Let's rename it to backtrackable iterator. Abbreviated. I don't like abbreviations, but I'm not calling this backtrackable iterator. That would be insane. All right, so let's run that test. And all right, we've still got give back not being a thing, so we can go in here and just comment that out for now. And that, I guess, will mean that our guiding test will fail as well as our new thing. So maybe we'll ignore our guiding test again. Oh, lots of things failing. Oh dear. I'm a bit surprised by that. It makes me wonder. Right, our guiding test failing, which is good. But look, other things are failing. How? What did we change that would break our stuff? Yeah, lots of tests are just producing nothing. So lexing's still working, but parsing has basically completely stopped working for any multi thing. Okay, so why? It must be. Well, let's do a bit of a diff. Figure out what we've changed in the parser that's breaking everything. Oh, look. Yeah. Okay. Easy. Good. All right. I thought it was going to be something really difficult, but it's not. Did you spot it? in parse next, if we hit a token, if we hit a lack of token, we're immediately exiting this function and returning none, which is totally wrong. What it should be is, if token was none, we just return the thing we've already got, right? It's fine. It's not some kind of, we didn't find an expression. It's just that there was nothing after the expression we did find. So I guess it's going to be let some token equal token, else return, and not return none as I was doing before, but return the thing that we've already got, which is expr. Right, run our tests. Please pass. Okay, they all pass except our guiding test, so let's ignore our guiding test again. Parse, assignment, and usage, this one. We're near the point where we can unignore it, but for now we're ignoring it. While we're here, let's just double check that all our parsing functions now take in that ignore list, because I think it should be just a completely, not ignore list, what did I call it? Ending list or something. So operation right operand does not take it in. Leave for operand does take it in. So end markers should get passed into operation right operand as well, I think. And that seems to be, we'll just double check, but that seems to be the last function in the parser. So now why is that not used? I would have thought that would get used. But yeah, okay, right operand at the moment is only looking for a leaf. So when this is more complex expressions on the right hand side of an operand, at that point we'll use these end markers, I guess. All right, that was just to make my that was just a complete deviation to make my parsing functions all regular, because they all take in end markers. Just double checking they all do. They all do. Now, where were we? We run the tests. They passed. So our give backable iterator, where is it? Backtrackable iterator. The one test that we wrote so far does pass, but it doesn't do anything interesting yet. So more tests for backtrackable iterator. I guess we could just go straight into, you can backtrack, right? You can push things in. Yeah, I guess we start off by just pushing things. Well, I mean, how much? The only edge case I can think of is pushing things when it's empty. So let's do that. And just not do that. So I guess it's can give back items to, and so items that are given back, items that were given back are returned, are provided, are yielded, because I used the word yield above. Next. So we've got a backtrackable iterator over something that's ABC. We're going to call a next on it. So we're going to call next. It's going to give us back some A. Does that work? Is that going to compile? This should be mutable. Looks happy. And then we're going to push some stuff onto it. Give back Z. And then we'll give back something else. So let's do X, Y, Z, shall we? like so. And then we're gonna get the next thing out. I guess let's just collect them now. So when we collect them, it should be, hang on, what should be next? Yeah, A, B, yeah, it should now be, we got rid of the A, so now it's going to be Z, Y, X, and then the B and C that we already had. And then the only other test that we want is if you drain it, items that were given back after draining. After draining are yielded next. So we could try just an empty backtrackable iterator. That might be interesting as well. But for this one, let's call next 3 times. Now, I don't think it would be fair of us to try collect on this, because that will give us, that will mean that we called next and got back none. And iterators don't guarantee that if you got back none once, you're going to get back none every time. So it's just, that's just confusing. So let's just not do that. Let's just say, right, now it's empty. Now we give back X, Y, Z, and you should get back Z, Y, X. And that's that. I guess we can also just do empty iterators. Empty backtrackable iterator can have items given back. I mean, we're always going to push back something that we've just pulled off. So all of these examples are a bit funny, aren't they? But let's do it anyway. So this is going to be created from a iter empty, I guess. And then we're going to give back, let's just give back one thing, shall we? That should look like this. So yeah, the thing about give back is we're actually just pushing some new stuff into it. But it just happens that when we're using it, it's always going to be something we just pulled out of it. But I think if we just implement this as you can push anything back into there, I don't think it's going to do us any harm. In theory, we could then start pushing things back in the wrong order or something like that. So if we get to that point where it looks like we might do that, we might want to revisit this. All right, so give back currently doesn't exist. So let's just make a kind of useless method for it. So where are we going to implement it? So why is new a warning? Oh, because this should be all. This is only done in test. Whereas give back in a second. Oh, I guess new is also going to be, it's going to be used in a second. So we won't just make it test only. We'll put up with the warning for now. So give back is going to take in a V. So what? It's working on a mutable reference to self. It takes in a V. And for now, we'll just do nothing with it. So these tests are going to fail. With any luck. Yep, it looks like they did. So, yeah, it was empty and it should have been X. It was empty, it should have been ZYX. It was BC and it should have been ZYX BC. And those are the only things that failed, but there are 2 ignored. Okay, so everything's working as we expected. Now what we need to do is implement this. And I think the way we're going to implement this is just... what are we going to call this? These are given back. Or something like that. It's going to be a vec of these. So every time you give us something back, we're going to push them into this this vector. I actually think it should be a vecdeck, because we're going to push in. No. It's no. It's going to be a vec, because this is just going to be like a stack. So when the most recent thing we pushed on is going to be the thing we pop off. So it's fine. So given back just needs to be an empty vector. So I'm just going to say default. So then if I change my mind about what given back is, this code will still work. So that just means make me an empty vector. When you give something back, we're going to push it in. Given back. Push in the thing we've been given. Why is this called V? Let's make this nice. Let's make it value. Or maybe item. Maybe item. That's not a great name. It's better than nothing. The test will still fail because we still haven't done anything with it. And then the thing we need to do is we need to implement next differently. So currently what next does is just calls next on the inner iterator. But what we need to do is check whether we've been given something back and return that first. So it's going to be, we want kind of the opposite of question mark here. We want to say if it's sum, return it, otherwise continue. So is there a way of doing that? I guess there's a and then or something, or else. Yeah, so I suppose it's going to be self dot given back dot pop, because pop gives you back an option. And if that was sum, then we're done. Otherwise, we need to do something, which is this. I think that's it. So we either get something out of given back, or if that given back pop gave us back a none because there's nothing in given back, then we do self.inner.next. So we'll only actually call this code if it was none, because this is like a closure in here. So if it was or, we would be bad. We would be popping things, pulling things from that internal iterator, even if there was something in given back. But because we used or else that takes a closure, this will only happen if that. So maybe that's fine. Are these tests now going to pass? Look, they do. They do. All right. Why have we got warnings in here? Because we're not using this code yet. So let's make it public and use it in parser to say, instead of us having an iterator, instead of tokens being an iterator, it's going to be a backtrackable iterator of I, token. I think that's a bit odd that we've got saying token here and here. We still have to say what I is. The other thing is, could we just make backtrackable iterator? No, the thing is, backtrackable iterator, it wraps any iterator. So we want to preserve that ability, I guess. Now, why is it complaining about tokens? Because, oh yeah, because we haven't actually, this is just the function that constructs the thing. This is where we actually do the thing. So right, where have we got to? So when we call parse, all right, so yeah, all right. So when we've got a lexer, we're not returning a backtrackable iterator. So I guess we need to wrap this up in a backtrackable iterator like this. This seems a bit awkward, but this is just test code, so we can write a little function and make it nice, and that'll be fine. There should be backtrackable iterator new, I guess. Okay, that seems okay. So let's see whether we can do that everywhere. And make our compiler errors go away, and then see whether we've got more serious errors. Now, we still need to do the same thing here. Yeah. So maybe parse should wrap. Yeah. Okay. This was wrong. The parse function should wrap the iterator we're given in a backtrackable iterator. We don't need to do it. That's what the parse function's for, it turns out. So here we get past just an I, but we wrap it up in a backtrackable iterator here. Now it's starting to make sense, I think. This should be tokens. Okay, now that is not very error-y. It's a warning that giveback is never used, but you know it is used. I'm using it in this code here. If I delete, oh no, okay. All right, fair enough. It isn't used. Now it is. Okay, so what if we ignore our test? Is this just going to magically work? It seems unlikely. You know what? It did. It did work. All right. So we need to do a serious recap of what we just did, because we, like I said at the beginning, we basically just implemented, like the kind of hard bit of parsing, of like the two bits of parsing that always confuse me are, when do I stop? Because I've reached the end, and how do I give back stuff that I was looking at? And actually, this backtrackable iterator is going to help us fix one of the problems we've got with our Alexa, which is that it consumes extra stuff, this white space or other stuff, that it shouldn't. So we're going to, in the next video or something, we're going to fix that problem by also using the backtrackable iterator, which is cool. And then we'll get rid of this annoying space that we had to insert here just to make our Alexa work. But yeah, let's think again over what we did. So what we did was we made this test case pass. Let's just triple check it really passed. I'm slightly surprised. So parser, what's it called? Parse assignment and usage. Yeah, it really did pass. So what it is we've got an assignment expression, let x equal 3. Obviously, assignment expressions don't make a lot of sense, but they are a thing. We've got an assignment expression, which is then followed by a semicolon, which means it gets wrapped up in a statement, which is what this is. And then we've got some other expression afterwards. And the bit that was missing was after we were partway through parsing this assignment expression, and we were trying to parse the right hand side, and it said 3, and we were like, fine, okay, it's a 3. But then we carried on parsing, because this might be, say, 3 plus 7 or something on the right hand side of this assignment. So we went to look for a plus, and we didn't hit a plus, we hit a semicolon. And at that point we didn't know what to do, so we just crashed. So what we needed to do was pass in a list of things to these. When we're parsing this assignment expression, we need to say to it that there is a list of things you need to stop when you hit them. At the moment, our list just contains this semicolon. So then it knew, okay, I need to stop because I hit the semicolon. So that meant that we'd correctly parsed this expression and stopped at the right time. But we also needed later, when we jumped back out in the code, to use that semicolon, even though we'd already hit it while we were trying to parse this 3, we also needed to use that semicolon to say, okay, the thing you've just parsed, it needs to be wrapped up because it's a statement. So we needed that semicolon to go back into the list of tokens, even though we'd pulled it out. And like I said earlier, most people that I've seen do this, they use a peaking model. So then the 3 wouldn't have actually pulled the plus out. It would have just peaked it. And peaking means like, tell me what's in there, but don't actually take it out. But I find that awkward. Like most of the time, we are actually pulling them out and we want to pull them out. And just occasionally we kind of regret it. We're like, oh, sorry, I shouldn't have taken that one. I want to put it back. So it feels more natural to me to give back than it does to peek. So that's why I've implemented that way, and we'll see how that goes. I haven't seen anyone else do that. I'm sure lots of people have, but it's not something I've seen before. So so far I'm pretty happy with it, I must say. Anyway, so where we've got to is we can lex this whole thing, and we can parse it, but we can't evaluate it yet. So if we re-enable the evaluator test that is the equivalent of this, this is a really cool test, right? This is the whole let x be 3, then add 4 to it, and you should get out 7, right? So this would mean that we'd written, this is like a programming language, right? An assignment followed by an expression. I guess next time we might do some tidying up, like fixing the lexer and stuff like that. But pretty soon we're going to be making this code actually run. I hope. Cool. I hope you enjoyed. This is, parsing gets confusing. And I'm sure as we get deeper into, especially when there's lots of possible things that might happen next, our parsing functions are going to get really complicated. But yeah, I hope you followed along with this and it made sense. Hope you're enjoying this series. Tell your friends about it. Have a fantastic day. Just be brilliant to the people around you. Just express your love any way you can, in a way that is appropriate and doesn't bear down on someone else. Just be kind, be excellent to everyone you possibly can. And I'll try and do the same thing, and maybe that'll be good. All right, see you soon.